Hello, so in this video I'm going to show you how to solve log and exponential equations. And there are two basic cases. So you have exponential equation. That's equation where you have variable in the exponent. So first thing you need to do is try to see if you can write something as a same base and different exponents. So for example, if you have 3 to the power of x equals 3 to the power of 2, then we can ignore the 3, so x equals 2. That's what this first rule says. And then if you cannot do that, then you take logarithm of both sides. We're going to do some examples, so this will be clearer. So in this example, we have 9 to the power of 8 minus x equals 27 to the x minus 3. So first thing first, let's see if we can write number 9 and 27 as something with a common base. So I will copy these exponents here and leave empty parentheses to see if I can come up with something. Well, I know that 3 times 3 is 9, so 3 to the power of 2 is 9, and I know that 3 times 3 is 27, so 3 to the power of 3. Now I need to simplify, so using rules of exponents, I multiply 2 times 8 minus x. I'm going to do this on the side. So 2 times 8 minus x equals 2 times 8 is 16, 2 times negative x is negative 2x. So I end up with 3 to the power of 16 minus 2x equals 3 to the power of, now I need to simplify this, 3 times x minus 3. So 3 times x minus 3 would be 3x minus 9. So 3 to the power of 3x minus 9. See, now I use that first method, and in this case I was able to rewrite both sides with the same base. Base is 3. So now I can ignore those bases and just focus on exponents. So since their bases are same, exponents must equal to each other. So 16 minus 2x equals 3x minus 9. I'm going to solve this equation. Just put 3x here. I'm going to keep positive 16 here. And next thing I will do that negative 9, move it over here, make it plus 9, move it to the left. Take that negative 2x, move it here, make it positive 2x. So I have 5x on this side, and I have 9 plus 16 is 25. 25 equals 5x, so x is going to equal 5. So from here, if 5x equals 25, then x is 25 divided by 5. So x equals 5. So this was the first case where we were able to rewrite 9 and 27 with the same base. Now let's see what happens when we cannot do that. So in the next problem, there is no way to write 4 and 5 as a number with the same base and different exponents. So the rule says if you can't do it, take a log. So we can take log of both sides. 4 to the x minus 1 equals log of 5. Now, I can choose log with base 10, but for me it's more convenient, and I can do so, to choose base 4, because if I choose log with base 4, what happens is that I can cancel number and the base. So log base 4 to the power of 4 will just cancel out. So I'm just going to get x minus 1 on this side. X minus 1 equals log with base 4 of 5. So x equals log base 4 of 5 plus 1. Now the only thing left is to put this in the calculator. Now I cannot, in my calculator I don't have base 4 or anything like that. So I'm going to use change of base formula that says that I can rewrite this here log base 4 of 5 as log 5 divided by log 4 plus 1. So I can go and type that in and see what that gives me. We have log 5 divided by log 4. That equals 1.16 something something plus 1 will give us 2.16 approximately. So x is approximately 2.16. And if you want check, you can take that x, plug it back in here. So to check, we can say that 4 to the power of 2.16 minus 1 should equal 5. So 4 to the power of approximately 1.16 should equal 5. Let's double check. So we got 4 to the power of 1.16, 4.99, so it's very close to 5.